Let's have a look at this question. Here, second order ordinary differential equation is given, that is homogeneous. We need to find the solution of the given equation. The coefficients of all the terms are constant, so the solution will be of the form y equals to e power mx. This is the general form of homogeneous equation with constant coefficient. Now let's substitute these values by obtaining y dash, that is first derivative of y with respect to x, that is equals to d by dx of derivative of e power mx, which is nothing but m times e power mx. Again differentiating this y double prime, that is second derivative, again derivating that, d by dx of m times e power mx, which is nothing but m square e power mx. Substitute these two in the given equation. We will have y double prime is m square e power mx, so m square e power mx minus y dash, that is y prime is m times e power mx minus 2y, that is 2 times y is e power mx, that is equals to 0. Taking e power mx common, we will have m square minus m minus 2 times e power mx, that is equals to 0. E power mx cannot be 0, so m square minus m minus 2 should be equals to 0 in order to satisfy the above equation. So by solving this quadratic equation, if we find the roots of the quadratic equation, we will have m square minus m can be written as minus 2m plus m minus 2 equals to 0. By taking m common, we will have m times m minus 2, then plus 1 as common, we will have m minus 2, that is equals to 0. So which yields m minus 2 times m plus 1 is equals to 0. Therefore the roots are m equals to minus 1 comma 2. So y is equals to e power minus x, or y is equals to e power m, that is 2x. This is the answer for given equation. So here it is C. Option C is the correct answer, e power 2x and e power minus x.